right, guys, here we go. So I've kind of gone through all of these. This is from 131. The biggest thing is you've got to kind of pay attention to the wording and what they're looking for. Uh, this one in general here, it's a calculator problem. So when you see that, you're going to be able to use your calculator. And especially since this thing is a little ugly, remember what the average value, it's one of the formulas you need to know. And it's going to be 1 over b minus a, the integral of f of x for the same interval from a to b. Okay, so if f of x is this, we're going to set it up as 1 over 6 minus 2, integral of 6 to 2, and that would be the integral of 3 natural log of 2 plus x squared cosine x. This right here gets plugged into your calculator. You can put this whole thing in if you want. And then that's what spits this piece out. Don't forget the front piece. That's what everybody forgets on the average value problems. A lot of this stuff is set up. This one here, they just wanted you to set it up. The question is, which of the following definite integrals, when you see this, remember, you can integrate it along the x-axis. So you can integrate it back and forth this way. And you can also integrate it up and down. They don't specify. So you can go up the x-axis and the y-axis. So you got to find 2. So if we go upper minus lower right here, we get this piece here from boundaries from 0 to 2, which is this one. And we end up with that right there. If you go the other way, and you solve these equations for x, which is why I drew this arrow here, this one here is subtracting 1 and dividing by 4. That's this one here. And then if I take the natural log of both sides and solve, I get natural log of y equals over the natural log of 3. Well, the boundaries aren't going to be the same, so that automatically kicks that one out. So we've got an answer of 9 and 1 and 0 and 3. And if you plug that into your calculator or plug one into the other, however you wanted to do it, plugging these in. So if you plug this in and got a 0, that'd be 1. If you plug 1 in here, you would get your different boundaries that you have here. So that's what they're looking for in that one to get an answer. So if you plug in, so like for 9 here, if you plug in 0 here, 3 to the x, you get 1. And if you plug in 2 here, your y value is going to be 9. If you do the same thing up here, it's going to give you the same idea. If you plug in 0, you get 1. Excuse me. So that's where this boundary come from. Whoa, I just ran out of gas, guys. This one here is a little split. Since it has 2 different shapes, you got to take the integral from 0 to 2. So it's going to be upper minus lower, which is that right there. And from 2 to 5, it's upper minus lower. So it's 7x minus x squared minus 10. So it looks a little different. So you got to integrate it and then evaluate it from 5 to 2. And then you've got to integrate it and evaluate this one from 0 to 2. And so once you evaluate those two, you're going to take this one and that one, and we're going to add them together. And that's how they get their answer of C. This one here is a washer method. Here, we're revolving it around the vertical line, x equals 3. So it's a washer method. It also is an integration on the y-axis because we rotate it around the x. So when we cut, we're going to cut a lot left and right. So we're going to integrate it on the y. So that means we got to solve all these equations here, this one here, and this one here, into values in x. So if I just flip this over, this becomes pi over 2 y, and then if I solve this one for y, I get the arc sine of both sides. And then we've got to deal with this negative 3 here. So if I take it, I can do y squared. I'm sorry, not y squared. Pi over 2y minus a negative 3, because I got to subtract it outside, which is this piece here. Outside minus the inside, and the inside's negative 3. So I get pi over 2y plus 3. And we've got to square it because it's the r squared, outside squared minus the inside squared. And the inside would be this equation here, which would be another way to look at this is if we do y, if you wrote it differently, y sine of x, how do I get rid of this? I got to take the inverse sine of both sides. And that's going to cancel this out. I'm going to get x. And remember, the inverse sine is the same as the arc sine. So that's where that comes from. And again, it's going to be arc sine, the outside, minus the inside. And if you subtract the negative, because this 3 is negative right here. Sorry, chicken scratching all over it. That's where we get the positive 3. This one was interesting. I was trying to mess around with it and doing it a little differently. Mathematically, I can't even fit it on this page. But I was trying to do half of it and change this into pi over 4, because if the integral from negative 1 to 1 of this piece here is pi over 2, then half of that from 0 to 1 is going to be pi over 4. And so this comes from solving for y. So if you move this over, you get y squared equals 1 minus x squared, and then y equals the square root of 1 minus x squared. That's where this piece right here comes from. So what they're saying is when you set this up, you got a top and you got a bottom. It's a full circle, right? Circular region. It's a full circle. So you got a top and a bottom. So you got to do 3 minus the square root of 1 minus x squared squared. And then you got to do minus. This doesn't work, guys. So that sucks. I haven't figured out a way to do it. And then you got to do minus 3 plus the square root of 1 minus x squared. And what happens is, and this is all from negative 1. Let's get rid of this, right? And what happens is when you take the integral of this and you have a negative 1x squared anywhere, it becomes pi over 2. You got to plug it in. And like I said, I can't do the math here. This is actually a pretty intricate problem. And so that's kind of basically the idea, is that you got to take the integral of the upper side and the lower side, and that'll give you your answer. This is a implicit differentiation problem. That last one is just total chicken scratch because it's way too big to put it inside there. So this one here is just an implicit. So if I take the derivative of that, I get 6x. If I take the derivative of this one, it is a chain rule right here. And then if I take the derivative of this one, I get 2 dy dx. The key is making sure you get your dyx's all on one side, and you take anything that's not a dy dx it's not attached to it, and you move it to the other side. So what you get is, and this doesn't let me write over here, so it's kind of irritating. What you get on the left side is you get 5x squared 2y dy dx, that's what that is, minus 2 dy dx. If I factor out the dy dx's, I'm over here like this. And this part of the answer here, I don't have a lot of room on this, guys. This part of the answer here is these two pieces here moved to the right side. So I took 10xy squared, subtracted it, put 6x on the other side. And then since I factored these two out to the front here of the left side, what's left is this part here in the box minus 2. And so I'm going to divide that to get it up to the other side. So that's where that comes from. And where does the 10 come from? 5 times 2. So give that a shot and see if you guys come up with that piece. Remember, don't forget the implicit differentiation right here in the middle. And don't forget to move everything that doesn't have a dyx to one side and everything that has a dy dx to the other side. This one is a theoretical problem. So as soon as you see mean value theorem, they're just looking for slopes of 6. This is a lot of calculations. So I did some arrows here. So if you go from 3 to 5, so from 3 to 5, we'll call that C1. That is a 6. So if you do 6 minus, if you do 18 minus 6 divided by 5 minus 3, you get a value of 6. That's one of them. So we'll call that C1. So that's the slope of C1. We'll call that C1. That's from the interval, let's call it from 3 to 5. And then if I go from 3 to 9, so I go from here, I'll do this one here, 3 to 9. 3 to 9 is going to be the same thing. 42 minus 6 is 6. 42 minus 6 is 36. Divided by 9 minus 3, that's 6. It gives you a value of 6. And we'll call that one C3. So C3 is equal to 6. And that's going to be from 3 to 9. They're on the same interval, so we're good. Now, we know that C3 has been calculated here. That's the interval from 3 to 9. And there's one more in here. And if you go from 5 to 9 and you calculate the interval right here, if you go from 5 to 9, you do 42 minus 18 divided by, which is 24, and you divide that by 9 minus 5. So we're just using the slope formula. You're going to get 6 also. So C2 from 5 to 9 is also 6. So we get all these things that equal 6. So there's 3 spots. We got from 3 to 5, if you calculate the slope here. We've got from 3 to 9, if you calculate the slope there. And we also have from 5 to 9, if you calculate the slope using the slope formula there. 3 spots. So initially you go, oh, well, it's got to be 3. Problem is, if you look at this, C1 and C2 are not on the same interval. In other words, they're not contained in the same interval. So 3 to 5 is not inside of 5 to 9. So we don't know for sure that they got to be in the same interval, remember. So 3 to 5 is in 3 to 9, so we're good. 5 to 9 is inside 3 to 9. And so since 3 to 5 and 5 to 9 are not in the same one, we can't count all 3. So we know it's a minimum of 2. It's either 2 here or 2 here. It can't be all 3. And then I skipped this one. I didn't even look at that one. So this one here, don't forget when you flip this over and make it from -2 to 5, this becomes equal to 12. We flip the sign here. So we're going to do a little bit of math to add these two together. So we've got 12. And so we're going to go from -2 to 8. And we're going to go from and we only want from 5 to 8, so we've got to do just a little bit of math, and that's why they come up with -7 there. So all right, so the next piece here, beep, 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 beep. This one here is a little tricky. You had to use this big ugly thing as u. So if we did that as u, we get a du of 20x to the 4th plus 15. This is one of those cheesy problems where when you factor out a 5 of this, if you factor out a 5, you get 4x to the 4th plus 3. And if you factor out a 5, when you bring it over, you get the 1/5 here. And so that's where that 1/5 comes from. And then 1 over u becomes the natural log of what u was, and that's why it's c. So this is the key piece. So if you look at this, this becomes 5 4x to the fourth plus 3. Sorry, I'm squeezing it in. And when you divide this to the other side, you get 1 over 5, 4x to the fourth plus 3. And that 4x to the fourth plus 3, and that one cancels. So that's what you get on that one. Don't forget, when you see this piece here, it's a slope formula. Remember, the basic idea of the slope formula is it's the limit definition of a derivative. So what is f of x? F of x is sine. So that we get what is f of x? That means f prime of x is negative cosine of x. What is cosine of x at 2 pi? Well, it's 1 times a negative gives us a negative 1. So there's the little quick version, ladies and gentlemen, and that's the one I have for you right now.